Okay, this is the fourth and final, you might say the most advanced of the IDRISI video tutorials, and you'll be familiar with the NDVI image that we've used in the previous two tutorials with the mountain range, but we can also see, using a different palette file, a representation of elevation, of height, or digital elevation model, DEM. And so now these different colours actually represent the different heights in meters above mean sea level in height. So you tend not to find much malaria in highland areas, and when you do get malaria in those areas it's quite bad. On the other hand, mosquitoes do like vegetation, because vegetation cover provides a nice microclimate during the daytime for mosquitoes to escape from the heat. So we're going to use two pieces of information, the NDVI and the elevation map of the same region, to generate a proxy for malaria risk. So the first function we're going to use is something called reclass, and reclass allows us to take an image with lots of different numbers in this example here for elevation, lots of different height values, and classify it according to a particular scheme. And in fact for malaria we're interested in a cut-off value of about 1500 meters, and anything above 1500 meters tends to be far too cold for mosquitoes to live, so you won't get any malaria there. So the first thing I'm going to do is reclass this image according to what we call a binary category, 0 or 1. So 0 means there's no risk associated with it, and the value of 1 means that yes, there is some risk associated. So there's an icon up here on the toolbar called reclass. If we click on that, the input file is Sierra-Dem, which is our digital elevation model. So Sierra-Dem is the image that we're actually going to reclass, and I need to give it an output name. And remember, the output files will always be put into the nominated main working folder from the paths setup that we do right at the beginning. So I'm going to call this Dem risk, because it's the risk associated with height. So it's very easy to use this tool. I'm going to assign a value of 0, which will mean 0 risk for malaria, to all values from 1500 to just less than 2000. Those are my cut-off values, and basically anything above 1500 it's very unlikely you'll get any malaria, you'll get any problems with mosquitoes, which means that everything less than 1500 there is a real possibility that there could be mosquitoes. So I'm going to give it a risk value of 1, which means that there is a risk from everything from sea level, which is 0 meters, up to 1500. If you click on the output documentation, it means you can just give it a title. So I'm going to say malaria risk associated with height. Okay, and if I click on OK, now it's done it. It's actually reclassified this image, and it's provided me with a binary reclassification where 0, the black areas, you won't find any malaria because it's too high up, and 1 are the low-lying areas below 1500 feet where potentially you could get some malaria. Now you may wonder, when I did this classification, how I knew what the maximum value was. Well, remember, you can find out when you have an image selected from layer properties, you can find out the maximum value here. So I knew that it was 1999, which is why I put a value of 2000, because I knew that that was the highest number. Okay, so we've produced a risk image associated with height. Now we need to do the same for vegetation. So we'll choose reclass again, and input image will be the NDVI image, and I'm going to call this veg risk. And now we're interested in classifying areas that have an NDVI of about 0.4 and above. NDVI is between 0 and 1, where you've got very low values, you've got very little vegetation. The higher the value, the greater the amount of vegetation. Obviously mosquitoes like areas with lots of vegetation, so I'm going to give value of 0, which means very little risk, to all values where the NDVI is 0 itself, where there would be no vegetation, to 0.4, which if you like you can think of it as 40% vegetation coverage, which is fairly sparse. So I'm going to give a classification of 1, which means that there is some risk associated with vegetation for malaria, to all values from 0.4 right up to the maximum value of 1. So everything from 40% coverage to 100% coverage of vegetation, I'll say yes, I'll classify that as having some risk. And again, click on output documentation, and I'm going to call this malaria risk associated with NDVI. So we're all happy with that, click on OK, and now we've got another binary image. So we've got two binary images, one which is giving us malaria risk associated with height, and the other is giving us malaria risk associated with NDVI, with vegetation. So what we can do is we combine the two together to get our overall risk, and the way we do that is using something called the image calculator, which is this button up here. And so in this example the image calculator will be an output which I'm going to call risk. I'm just going to call it risk because it's the overall combination of these two added together. So you can actually treat images as though they were terms in an equation. So I'm going to make a little sum, which is the malaria risk is the combination of, and you click on insert image, dem risk, which is the risk associated with digital elevation or height, plus veg risk associated with vegetation. So essentially I'm adding these two images together, and we just click on process expression, and there we go. This is our combination of these two added together. We arithmetically add these two images together. We get something between 0 and 2, because where the two values of 1 intersect, they add together to make 2. Where you've got two zeros, you just get 0, and we get 1 or the other, then you get a value of 1. So this isn't a very useful colour scheme we've got here, so I'm actually going to create a palette file just for this risk. So I click on the symbol workshop and select File and New, and select Palette, and I'm going to call this malrisk. Okay, so value of 0, I'm going to make that yellow. A value of 1, I'm going to make that orange. And then the value of 2, which is the highest risk category, I'll leave that at red. And then just click on File and Save, and then we can exit from there. So now I can apply that by clicking on Layer Properties and changing the palette file to malrisk, which I've just created, and click off Auto Scale. So now what we've got is a risk map of malaria for that region in 3 categories of increasing risk from yellow, orange and red. And we can dress this up a little bit, so we can add from the map properties a north orientation arrow, and we can add a scale bar, and we can change the units to meters. We can move these map elements so it looks nice. So that's my final risk map, if I wanted to, I could add a title here, so I can call this malaria risk, and a subtitle based on height and vegetation. And that's it.